So your first question here says, when is a conjecture proven to be true? Well, it might help if you first knew what a conjecture was. And a conjecture is kind of like a theory or an idea. And those ideas or theories kind of almost similar to a hypothesis. They're considered to be proven when it fits logically with rules that everyone knows to be true. So whenever a conjecture or a theory fits logically with rules that everyone knows to be true, then we know that the conjecture is also true. So we're talking a lot today actually about what we call Venn diagrams. And you've seen Venn diagrams a lot. You just probably don't know that's what they're called. A Venn diagram is a tool that is used to picture how logic works. Venn diagrams are circles. You may see them like this, where it talks about things that are blue and things that are white. So you do not have to write this example. In the white box we could put cotton. In the blue box we could put North Mesquite High School, because they're the blue school. In the middle, where they're overlapping, we could put like the sky, because the sky is both blue and white. So these things here are things that are part of both. Another example is given to us below. They have this statement that says you can use these Venn diagrams to help depict if-then statements. And that's what we're really going to be doing with them. So, for example, if you had a statement that said, if a thing is an apple, then it is a fruit. And then they gave you these other words: apples, light bulbs, baseballs, pears, lemons, cherries, oranges, strawberries, and bananas. And you're supposed to write these words in the appropriate place in the Venn diagram. So if you look at the next page, they have given you a Venn diagram, and we're supposed to write in this big circle here is everything that's a fruit. Well, from that list, the things that were fruits were apples. Well, they're going to go in the apple circle because they're also an apple. And then the next word we had was pears and lemons, cherries, oranges, strawberries, and bananas. You had some other words there, such as light bulbs and baseballs. And we're going to write those words outside the circle, because everything that's in the circle is represented by what the circle represents. Well, this circle represents fruits. So everything that's written in this circle is a fruit. And then everything that's written inside that inside circle is a fruit, and it's an apple. It might be easier if inside of this circle you had maybe written the word, and you do not have to write this, by the way, but I'm going to erase this part. We're going to use the same words that they've given us, and we're going to redo this. Again, you do not have to do this. And instead of apples in the middle, I'm going to write the word red. So that means anything in this circle the inside circle must be a fruit, and it must be red. So in our outside part, we would still have lemons, because they're not red, but they're fruits. We would still have pears, because again, they're not red, but they're fruits. We would still have oranges. And we would still have bananas. But on the inside part, we would also now have cherries, apples, and strawberries, because all of those are fruits and they are red. So you have these two statements. You're supposed to circle the correct answer. It says, if you took an if-then statement, inserted a not in each clause, and reversed it, the clauses, the new statement would also be true. Well, that's kind of confusing. So let's go back to our statement we had a second ago that said, if a thing is an apple, and I'm just going to write this, it was on the previous page. If a thing is an apple, then it is a fruit. So the first sentence is, if you took an if-then statement, inserted a not in each clause, and reversed the clauses. So that means that this, by the way, is the first clause. If it's an apple, the second clause, it's a fruit. So if I reversed it, that would mean that the fruit would come first, the apple would come second. If I put not in front of there, then that would mean that we would be saying that if it's not a fruit, it's not an apple. If it's not a fruit, then it's not an apple. Well, that statement is true because if you have something that is not a fruit, there's no way on earth it can be an apple. The second statement says if you took an if-then statement, inserted a not in each clause, or reversed the clauses, the new statement would also be true. So that's saying if we inserted a not or reversed it, not doing both. So then we could say if it's the first option be it's not an apple, then it's not a fruit. The second thing would be that if it's a fruit, then it's an apple. So the first part, insert a not in each clause. So not an apple is not a fruit. Well, that's not necessarily true because you could have a strawberry and that's not an apple, but it is a fruit. So that wouldn't work. That's not going to be true. The second part said that you or reverse the clauses, which means you just switched them. And that would be if it's a fruit, it's an apple. So that means if you're holding something as a fruit, it has to be an apple. That's not true either, so that's false. These switching around of things actually has names, and those names are converse, inverse, and contrapositive. I know those are funky words, but it's going to be okay. So what a converse does is a converse just flips the statement. So if our statement was, if a thing is an apple, then it is a fruit, then when we switched it, our new statement would say, if a thing is a fruit, then it is an apple. That would be the converse. The inverse of that statement, okay, inverse says if a thing is not an apple, then it is not a fruit. And the last one, a contrapositive, combines those two together and flips it and makes them both not. So it would say, if a thing is not a fruit, it is not an apple. Now, there are what we call logic notation that I'm going to write over here to the side, and you have blanks for that on your notes, that will help you as far as your quiz goes, because you're actually going to see this logic notation quite a bit. So the way we write in if-then statements, the way we write them in logic notation is if a thing is an apple, so I'm just going to use the letter A to represent apple, then we would say it implies that it's a fruit. To say that something is implied, we draw the two lines with an arrow. So that means if it's an apple, it implies it's a fruit. The notation for a converse would be the opposite of that it would be a fruit implies that it is an apple. The inverse says not an apple. To write the not symbol, we're going to do kind of a sideways L. So not an apple implies not a fruit. And the contrapositive says if it's not a fruit, that implies that it is not an apple. So this is the shorthand, or this is the notation that we can use for logic statements. These notations are going to come in very handy because they are going to be on your quiz that you're going to take. Of these three, what we call alternative statements, converse, inverse, and contrapositive, the only one of those that's actually true is the contrapositive. And we talked about that up here. This number 1 up here is the contrapositive. Number 2 is talking about the converse and the inverse. So the method of what we call syllogism, this is another funny word, syllogism, allows you to combine related conditional statements. So, and the phrase we describe it is, it's kind of the definition, says, if X implies Y and Y implies Z, then what we can do is we can jump and say that X implies Z. A statement that would probably help you comprehend this, what this really means and how this works, and I'm just going to write this, you don't need to, is instead of saying if X implies Y, then I'm going to say living in Dallas. Oh, let's try this again. If you live in Dallas, then you live in Texas. And then we could all say if you live in Texas, then you live in the U.S. And so because we've made those two statements, and because the last part of the first one, you live in Texas, is the same as the first part of the second one, you live in Texas, what we can do is jump from the first part to the last part. And if you think about that, that is true. That if you live in Dallas, you do live in the United States. That's an example of syllogism. So if you live in Dallas, then you live in the U.S. And so we jumped from the first statement to the second statement, but that only works if you notice that this middle part here was the same. Okay, and that's the same if you go back to this statement up here at the top. It says, it's described by the statement, if X implies Y and Y implies Z, so Y is there for both of them. So then we can jump from X to Z. So here we have another example of a Venn diagram. And we have one circle that are words that start with S, and the other one is words that end with Y. And we have all of these words up here that we're supposed to write in. Well, soap starts with S, so it needs to be in the starts with S circle. Salty starts with S, and it ends in Y, so that means it has to be in the part that overlaps. Saturday is the same way. And windy only ends in Y, so it's going to be in the other circle. This is just another example of a Venn diagram and how they work. The last part says, what is the contrapositive of the following statement? So remember, the contrapositive is, and you can flip back to the previous page, the contrapositive says that you flip the statement and you make it both nots. And so then the contrapositive would say, if tomorrow is not Saturday, then today is not Friday. Okay, moving on to the practice. All right, so it says, we're going to look at number 1. Which of the diagrams below represents the statement, if it is a square, then it is a rhombus? Now, what they're telling you, if something exists that's a square, it also falls into the category that it's a rhombus. And so here's the important thing here. Whatever comes first in the statement in question is always the inside circle. Okay, whatever comes first in the statement in question is always the inside circle. So in this case, it's going to be the one on the left. If something is a square, then it is a rhombus. So, and if you look at this, it makes sense because everything that's a square is inside of that rhombus circle. The other one is not true. There's pieces here that are squares, but they're not considered a rhombus. Looking at number 3, you've got to be careful and really pay attention to what they're asking you. It says, which of the diagrams below represents the contrapositive of the statement? If it is a rectangle, then it's a quadrilateral. Before we can actually figure this out, we have to first figure out what the contrapositive is. Contrapositive says that we flip it and we make them both not. So it would be not quadrilateral is not a rectangle. And that's the answer we're looking for. So again, whatever comes first is what goes on the inside, so that makes the one on the left, again, the correct answer. 5 says, what is the converse of the statement below? Well, converse, if you can look back at your notes, it's on page 2. The converse just says that we flip it. That's it. So the statement here says A implies B. The converse of that would be B implies A. Number 7, we can't see all of it, but it says, what is the contrapositive of the statement? So we're looking at M implies N. Contrapositive says we flip it and make them both not. So this would be not N implies not M. And number 9 says to write the converse. And again, converse just says we flip it. And so that would say that if I am awake, it is 9 a.m. That would be the converse. So pay very close attention to what they're asking you for.